In this example, we're going to solve this linear system using elimination. So the first thing to do is to make sure that the equations of the system are written in standard form. That is, x, y equals a number. So it appears that both of these equations need a little bit of work. So I want the constant to be all by itself on the right side, and this 4 is on the right side, but we have this plus 2y. So we're going to subtract 2y from both sides. So I'm going to rewrite this first equation, 3x minus 2y equals 4. So now I have x, y equals a number. Okay, let's do the same thing for the second equation. This negative 19 is a constant, and he's on the right side. But I need to get rid of this 3x. So I'm going to subtract 3x from both sides. So I'll end up with negative 3x plus 5y equals negative 19. And the reason I put a plus sign here is because this 5y is positive. Okay, so now elimination tells us that we need to add these two equations together in an effort to eliminate one of the variables. But of course that will only work as long as the coefficients of the variable we're trying to eliminate are equal in number but opposite in sign. So it looks like our y's are opposite signs, but they don't have the same numbers. So if I add these, they're not going to cancel out. However, our x's both are 3. The first is positive, the second is negative. So if I were to add these together, 3x minus 3x, they would cancel out. So let's go ahead and do that. So 3x minus 3x cancels out. Negative 2y plus 5y makes 3y. And then 4 minus 19 is negative 15. So when I divide, I'll see that y equals negative 5. So at this point now, I can take that value that I know is for y and just plug it into one of these original equations. I'm going to go ahead and plug it back into the top equation because we're solving for x, and x is almost by itself here. So this is 3x equals 4 plus 2y, and y is negative 5. So 3x equals 4 minus 10. 3x equals negative 6. So my value for x is negative 2. So I have now effectively solved this linear system using elimination. And the solution then is the ordered pair, negative 2, negative 5.